All right, good afternoon, everybody. Let's talk about security. Yeah, okay, that's the usual reaction that we get there. All right. So as we all know, security is not a technology problem, it's a business problem. Having said that, we're going to spend the next 45 minutes talking about technology to address security issues and the stuff that you can do in Couchbase. So I'm Darin Briskman. I'm from Couchbase Professional Services. With me here is the esteemed Dom Pinto, who is one of our engineers. So if this stuff works, it's because my team implemented it right, and if it's wrong, it's because his team didn't code it correctly. Let's see how it goes. Yeah. So Don and I are going to split the honors today, and because we must be legal, we'll start by saying we're going to be talking about some of the things in Couchbase 4.0. Couchbase 4.0 is not out yet, so therefore some of the things we talk about may or may not be true, depending on what happens in the future. Or as the great physicist Niels Bohr famously said, predictions are hard, especially about the future. But we'll try to avoid making those mistakes. Okay. So when we get down to what is it that matters in security, it boils down to 5 key areas when we look at our security framework. And that, of course, is authentication, authorization, encryption, auditing, and administration. So what are the things to do in there? And what we're going to do over the next 45 minutes is take a look over what is Couchbase able to give you in those areas. What are the technologies we have to enable your capability to create a secure environment? And then a nice demo that Don will show us about how does this stuff actually look and work when we're looking at some of the new features that have gone in there.
Okay, cool. So we'll start with kind of talking about our security journey so far. I know a lot of you have played with Couchbase, but some of you are also want to know what's existing in the box, what do we already have, and also you're here to understand what's new in 4.0. So if you look at our journey so far, we have worked on a lot of different features. Every single release that we had, starting from 2.0, 2.2, 2.5, 3.0, and even in 4.0, which I'm going to show you, included some security features. And in the next few slides, I could read all of the names here, but all the feature names here, but they're kind of boring. So in the next few slides, I'm going to kind of walk you through some of the capabilities that each of these features provide, or some of the security controls that you can use within Couchbase Server. So we'll start with authentication first, right? So authentication again is helping you log in or authenticate your identity to Couchbase. And there are a couple of different mechanisms here that we support. So if you look at the personas that you have of users which are coming into the Couchbase cluster, there are 2 kinds of personas. There is the application that application developers build. And there's also the admin user. So some of you may be admins here and who are using the Couchbase admin console to kind of administer the cluster. So in reality, there are 2 kinds of personas for the Couchbase cluster. So with the application authentication, what we have supported today is the concept of buckets, where it's a logical collection of documents, JSON documents, and you need some way to kind of have your application authenticate to these buckets so that they can use the data stored in the buckets. And so what we have for that is a bucket password that you can set up on a per bucket basis. And your application, all it needs to know is the bucket name and the password. And the password is passed through a simple challenge response SASL protocol to the server. So authentication happens over CRAM-MD5, and what you see in that small snippet there is when you do set up a bucket, you have 2 options. Like there's one option which you can say, I don't want any access control on the bucket, and there's another option which says, you can enter a password for that bucket and then protect that particular bucket. So that's a little bit from the authentication for the app. Now let's look a little bit on the authentication for the admin. So for the admin, when you set up Couchbase, your Couchbase server asks you to kind of input administrator username and password. And that's what we mean by admin username and password there. But with 4.0, we also added this new capability to kind of authenticate admins through LDAP. And that's what I'm going to talk about next. So why authentication with LDAP? Why is that so important, right? So first of all, LDAP gives you centralized identity management. You probably already have an LDAP server running in your enterprise that are already kind of like users defined in LDAP, trees defined in LDAP, or kind of hierarchies defined in that. And you want to leverage these existing identities to kind of in the Couchbase environment as well. Right, and so focusing on admins which are defined in LDAP, what you can do is you can take these admins in LDAP, which I'll show you the architecture in a little bit in the next slide, and you can map these admins to either read-only admins or full admins in Couchbase. And what that allows you to do is reutilize your existing policies. So you might have policies, for example, strong passwords or password rotation or password lockouts. All that policies that you already have defined in your LDAP server today still apply to Couchbase. So you don't have to do anything additional in Couchbase. Whatever the policies that you set up from an enterprise perspective on your LDAP server still apply. In addition to that, from a Couchbase perspective, you also get individual accountability, and we'll kind of see that next when we go into auditing, and it helps you get a simplified compliance experience. Because you don't have a single admin user when you start using LDAP. What you have is individual identities for each of your admins. So you may have an admin like Don, you may have an admin like John, so you could define two different users, admin users in LDAP, and then map them to admins in Couchbase. And obviously have then comprehensive audit trails for each of these admin users in Couchbase. So a little bit on how the architecture of the system is designed, right? So you have the admin console that we talked about. So the admin user, you pass in the the username and password, and before you even do that, what you can see on the right is you would have your UIDs defined in LDAP. And when you have your UIDs defined in LDAP, you need some way to map these UIDs to Couchbase. So you could go in the Couchbase UI, which I will show next, and then map some of these UIDs that you define in LDAP in Couchbase. But on the left side, the workflow pretty much is that when you enter a username and password in the console, it gets passed on to Couchbase, which then first checks the password file. So what do we mean by the password file there? So whenever you set up or configure the system to use LDAP, we don't really go to the LDAP server first, because there is also, when you set up the cluster, you still have a password file. We want to avoid lockout scenarios where, let's say, your LDAP server is offline, you should still be able to administer your Couchbase server cluster. So we always check the password file first to make it, if it's a password in the password file, then we basically we can start just log into the cluster and authenticate. But if the LDAP server is enabled, we don't, after the password file, let's say the user is not in the password file, we go to the LDAP server, which is then driven by a config file where you can set up your LDAP configurations for that, and then go to the LDAP server and just authenticate whether it is yes or no. It's basically a simple success or failure, whether the user exists in the LDAP server and the password matches. So that's pretty much the basic underlying architecture of how Couchbase on the left ties with LDAP and LDAP infrastructure on the right. Yes? So in this case, it's the username. Yeah, you would define usernames. So it depends on how you would set up your config file as well. So you could define in the config file the granularity of what you want, what token you want to really pass. So you can really pass in the username or email address or whatever, and then map that. So it could be any string for the first object, and the password, which is a string as well. So the UI is very simple. So if you download, do get a chance to play with a beta build, which I highly encourage. You can start using this new tab called LDAP Auth Setup, and you have a simple enable disable checkbox to enable LDAP. Put the users in the respective, I would say, text boxes there for mapping them into the respective roles. And then you can also set some default policy. Let's say a user is not mapped in Couchbase. What kind of, does he become a full admin? Does he become a read-only admin? Or does he have no privileges to get authenticated to the cluster? And you can also have a simple UI to kind of test whether the password matches, is it a valid user or not. And finally, all of this can also be kind of configured using REST and CLI. I know a lot of you set up your clusters in a programmatic fashion and not using the UI. So all of this that you can see in the UI is also programmatically set up. So the next thing, next topic I'll talk about is authorization before I pass it on to Darin again for encryption. So for authorization, what we have is, what authorization is, it kind of tells you what a user can do within Couchbase. So again, going into our two personas there, you have the application data access and the admin data access. So today, as I mentioned, like if you have the application, the bucket name and the bucket password, the capability that we provide today is you have full admin, full access to the specific bucket. So you can read and write or do a delete on a document in the bucket. With admin access, the authorization model currently is, as I mentioned, support for full administrators and read-only administrators. So full administrators can pretty much do all the operations in Couchbase. They can look at stats. They can set up, like for example, buckets, drop buckets, look at data, pretty much everything. And then the read-only administrator is pretty much you can think of it as a role if you use LDAP, where you have a bunch of users configured as read-only admins, and all these users can do is they can basically they can't change any of the cluster settings, they can't see the data, but they can basically see some of the stat operations or statistics of various elements and within the cluster and see some of the settings, but they can't change any of them. So now I'd like to pass it on to Darin to kind of talk about the encryption piece.
Thanks, Don. So encryption we do with a partner of ours called Vormetric. And when you're using Vormetric, you actually have the tools to go ahead and do both the encryption and the key management to be able to encrypt both data at rest and data in motion. So Vormetric has a session tomorrow afternoon. If you have an interest in encryption, I'd recommend that you go take a look. Where they'll be showing the really impressive lack of performance impact when you turn on the encryption. There is some impact, but it doesn't slow things down as much as you would expect they would. So for data in motion, that is, whenever you're doing client server, you should be using SSL, right? As we generally recommend. As you probably know already, when you're dealing with Couchbase, the default port for everything is 8091. But if you're using it secure, the default port is 18091. And in most production environments, that's what we're going to recommend you be doing, as well as using, again, the view access instead of 8092 is 18092. And also using XDCR in a secure mode when you're going across data centers. So we generally find that, certainly for data in motion, it makes no sense to ever be doing this in a non-encrypted environment, at least for the use cases that we find. For the data at rest, whether it makes sense to encrypt or not, that is more of a question of your use case in your environment, but the tools are there from our friends at Vormetric. And this is the Vormetric transparent data at rest solution. So this has the tools in it to secure user profile and login credentials, secure IP addresses. They have some really nice stuff about managing the keys. And I think this is particularly important if you're running your environment on the cloud, because you never know who has physical access to your storage devices when you're out there in a cloud environment or hosting environment. This way, you can at least make sure that somebody who gets illicit access to your stuff, all they get is gibberish because it's encrypted data. And that's very useful. If you're running inside your own secure data center, it's still a good idea, but maybe not as critical as it might be. Sure.
So the next feature of 4.0, which we'd like to talk about, is admin auditing. So we talked a little bit on what the capabilities that what admins can do, how you can use LDAP to kind of map them to either a read-only admin or a full admin, depending on your how you want to do it in your particular environment. But the next thing is for proper accountability and also for compliance reasons, auditing is also an important piece of the solution. So before I go into the details of how auditing works, when we were designing auditing in 4.0, we kind of talked about what are the 3 tenets we want out of our auditing solution. So the first one was rich audit events. And what I mean by that is we have over 25 different admin audit events, which are fairly rich. And there's everything from IP addresses for a remote IP address to what particular bucket name was deleted and all sorts of information. I'll show you an example in a bit. We also wanted we also audited tools like backup. So tools like backup where typically you would have let's say a third party which would kind of let's say do a nightly backup, for example, in some cases. Even those users who are coming in as an audit with an audit admin privilege should be audited. The next thing is configurable auditing. So since we're building this auditing solution, we were looking at what are the different kinds of outputs users want for the audit records, and where should these audit records go. So what we decided is to go with a configurable file target. So you can just point this file target to say, hey, I want it to go to this location. And we write the audit logs in JSON format in that target. So now you may choose to, for example, set a target to be a remote target and then maybe kind of sandbox that target with external network level like kind of security kind of ACLs on that particular remote location. And we also have the support for log-based time rotation and audit filtering. So what that is after a particular period of time, you can basically say, hey, I want to write another audit log file. And you can do that on a daily basis, monthly basis. That can be kind of, all of that can be configured. And also audit filtering. So I talked about 25 different audit events, but you may say, hey, in my use case, I really care about only login and fail logins. I don't really care about creating a bucket or dropping a bucket or any of those. So in that case, you can set audit filtering to kind of only emit those events which are relevant to your use case. And finally, integration, right? So we have these audit records, which I said in JSON format. And so we wanted, the whole choice of JSON was to allow for easy downstream integration, whether you're using a tool like Splunk or ArcSight or any other tool which you write, let's say a dashboard tool which can then operate on JSON. Or even, let's say you want to use Couchbase and Nickel, what you learned like this morning, to kind of just take some of that audit data, load it into a new Couchbase cluster, and then secure the cluster for auditing purposes, and then build like a dashboard on Nickel. That's, you can choose to do that. So when we talk about the 25 different audit events, I won't go into each and every one of them, but you can see that they're fairly exhaustive. This is a fairly exhaustive list of pretty much all the admin actions that the admins can do today with Couchbase and 4.0. And an example of such an event is a login, right? So a login event, for example, has a couple of fields here. You can see the first field is describes when the event occurred. The second field describes what happened, like, in this case, it was a login success. The next one was who. In this case, it is B. Jones. Note that it's not administrator because in this case, the user set up LDAP. So in this case, that was the username, B. Jones, that was trying to log in. It also gives you other information like how. In this case, it's the remote, the IP address and the port and so forth. So these audit records are fairly, detailed, and they're different. In this case, we're having login events, so the fields are very login specific. But you may have a create bucket event and where you have a bucket name and other bucket details, for example. So the next thing, I'd like to pass it on to Darin now to kind of talk about the architecture all up.
So those audit events, is that Couchbase 4?
Yes.
Yeah, so that is one of the key features that we're putting into Couchbase 4 that's new. On the other hand, when we talk about this kind of secure administration, it's kind of been true all the way back since the beginning. That when we actually do the administration, we lay it out, you're going to have a Couchbase cluster, and then in front of that Couchbase cluster, you're going to have some sort of application servers. So here we call it a web server. Yeah. You can argue that everything Couchbase by definition is a web technology. That's a semantic difference I won't get into. But some sort of web, some sort of application server, and it's usually, it's considered best practice to have some level of firewall in between. And these days, traditional firewalls, which are based on protocol, are probably not going to be doing you a whole lot of good in a world where almost everything passes over HTTP protocols or some variant of them. So we really want to have something there that can do some packet inspection, some filtering, and making sure that the data that is going in and out of your Couchbase cluster is only the data that should be going in and out of your Couchbase cluster. Typically a load balancer in front of those application servers. And then we, again, want to have another firewall, and again, typically something more than the traditional protocol-only firewall, that gives us the ability to block out inappropriate access from applications and from end users. Or I should say from end users who shouldn't be getting that access. So, this is, to a large degree, not very Couchbase specific. This is Administration Environment 101, but I am regularly shocked by how often people take systems with PII data and stick them on servers that have open internet access. This is particularly true in cloud environments. Okay, just because it's your Amazon account doesn't mean the rest of the world can't trip on that IP address. You still have to do basic security protocols and basic security hygiene to keep your environment secure. So a few things that we will pop up to think about. So packet filtering, we want to block malicious IPs. We want to make sure we have the right ingress and egress ports. In the Couchbase documentation, it does list explicitly what ports are there and what ports are open. If you're following our advice earlier and use the best practice of only using SSL, shut down port 8091 and 8092, and now in Nickel 8093. There's no reason to use them. Should all be under 18091, 18092, 18093 for the people who are doing the valid. Can we change that port from 18092 to something else? So Beta asks, can we change the port from 18092 to something else, or from any? Yes, all of the port numbers are configurable. Now, when you do that, whenever you call support, they're going to immediately say, hey, you've got the wrong ports enabled. So just be ready for that. And if you're going to change the ports from, and we've had several clients who have done this and said, okay, yeah, I'm already using that port for something else. I've got to change it. Yeah, it's well known, right? So one reason is well known. You want to do security with security. The other reason that I've seen is, we use that port for our own application. We need to do it. So changing ports is not bad and not a bad idea. Just make sure you document that clearly so people know how that happened. Down at the bottom layer, again, we want to make sure that Couchbase has the right ports allowed. Turn it the other way around, sir.
So is port 8192 the turn of data can be configurable?
So is it configurable for 8091 and 8092 and whatever, every single port in Couchbase? You can change that from the default values.
So you can turn off from the configuration?
You can turn off configuration. You can change. Now, obviously, if you block port 8091 and you don't map it to something else, you're going to find it very, very difficult to communicate with the machine if you're not doing SSL through 18091. So I have seen environments that are so secure they blocked any ability to do a query against a database, which is probably a little too secure when you get to that point. But having said that, all the default ports are indeed configurable. You can change these numbers.
Completely shut it off. What is the best way to turn it off?
So I'm sorry, I don't understand the question.
What is the best way to turn off those ports?
What's the best way to turn off those ports? That's something a little beyond the scope of this kind of a lecture. So we can either take that one offline, or I can show you in the documentation that there actually are sections that discuss how to configure the ports in Couchbase and do that. One that you do need to make sure you do keep open, though, is the node-to-node ports on Couchbase. So Couchbase has a range of ports that get a lot of traffic, because you should all know enough about Couchbase architecture to know that Couchbase is very chatty between the nodes, right? I'm constantly writing the replicas out, I'm constantly doing heartbeats, I'm constantly talking to each other. So those ports need to be open, and they're going to have a lot of traffic between them. So there is some in-depth best practices at a URL that I can barely read from here, but will be pretty clear online, and that is, or if you just Google for, or use your favorite search engine for Couchbase security best practices, you'll run across these entries. So, a few questions to ask yourself when you're doing this kind of administration. So one of them is, which ports are open through the firewall? Talked about before. And ideally, if you're using a more sophisticated firewall, what kind of deep packet inspection am I doing? What am I allowing? What are my vulnerabilities to hackers? For the first time last week, I heard the term NoSQL injection, which is kind of cute. But yeah, can somebody put a malformed data set against your application that will open up vulnerabilities or allow things in it? By default, Couchbase won't do that, but depending on how the application is written, that kind of vulnerability could be created. I've seen Java applications that you could send malformed data that would get you either privilege access or just data queries that you shouldn't be able to get based on how the application was written. Down at the bottom end is there admin access and data access separation? Am I designing the environment? Do I have, because just because somebody's an admin doesn't mean they need to be able to get into the buckets, right? My admin should be able to create a bucket and delete a bucket. Doesn't mean they need to read any of the data in the bucket. So especially in operations environments, that's something that should be clearly delineated, is who has the access to do administrative work versus who has the access to do the data work. And of course, is sensitive data encrypted? And another way to say that is, do you have any data that's sensitive at all? Because if you have any data that's sensitive at all, you pretty much need to encrypt everything. It's really hard to separate. It's more work to segregate out the non-sensitive data than it is just to encrypt everything in today's environments and today's tools. And finally, if I am using cross-data center replication, is that secure? So am I doing that properly? I have run across a few of our clients who had a really well-secured environment, and we're doing SCCR to some hosting provider in another continent, and that was completely wide open and anybody could access it from the open internet. So when we're going to do replication, remember both sides of replication have to follow your security policies. And of course, backups. If I'm doing backups, are those encrypted? And you know, given today's disk and tape encryption technology, it seems silly to do a backup that isn't encrypted. So that's a simple one and an easy one. Another one that I see people forget a surprising amount of the time. And my very, very last point here, which is the storage world. What happens if a disk goes away? Now, usually you're thinking that in failure, but there's also, what if somebody steals a disk or gets out there? Or if, God forbid, you have something like what happened at a major hosting provider on the East Coast in the US about 9 months ago, which it was discovered there was a child pornography operation that was using that hosting provider. So the FBI came in and walked away with 1,500 disk drives. Now, those disk drives did contain the illegal material, but those were striped across those drives, and they contained a whole lot of customer data. So was that customer data handed over to the FBI? Did they do something with it? I don't know. If that was my data, I'd want to make sure it's encrypted. So think through about what happens with if the disks disappear, if they walk out of the server. All right, so 2 more things we're going to do today. One, we want to show you how this actually works. And then second, we want to talk about what's coming next. You've seen a lot of exciting things and what we're doing, adding the auditing and new stuff into 4.0. We have exciting plans over time. But first, Don, how does this work?
So what you'll see next, and if I can use one hand to operate my computer here, is a demo with Couchbase and Splunk. So just a quick show of hands. How many of you use platforms like Splunk today to analyze other log files? Okay, quite a few. Okay.
That looks like about a third of the people here.
Thank you. So what you can see here is the Couchbase admin console. Thank you. So much. Okay, so what you can see here is the Couchbase admin console. I'm going to sign out here so we can start logging in again. So I'm going to log in to the admin console here. And on another tab, what I have is a simple Splunk dashboard. So I didn't have to do anything special to kind of create this dashboard. Yes, I had to create these widgets and specify what are the kind of queries that each of the widgets display data about. But in terms of ingesting the data from the Couchbase audit records that we kind of talked about earlier, it's pretty simple. So under settings in Splunk Enterprise, there is a connector like data inputs, and this is an out-of-the-box connector. And under that, you can just point it to file and directories. And what I set up here is a simple connector that points to my Couchbase logs location. So first of all, where does this location come from? So if you go to the admin console and you go to, this is a 4.0 build, and you go to settings, you will see that there is a new tab called audit. And this is where you can set up auditing in 4.0. Very simple UI, which enables you to enable or disable auditing. By default, we disable auditing when you kind of download Couchbase because yes, generating the log files does have some overhead. But again, remember, this is only the admin side of the equation, and we don't we don't feel that admin operations are pretty much as intensive like as data operations. And then we have this audit log target where you can specify by default it's just pumped into this Couchbase logs kind of location. But remember, you can change it to the location that you want your audit logs to be. And finally, the audit log rotation interval, which is in days. So if you go back to the UI, what I'm going to show you is what I have here is also a terminal. And what I did is I just tailed that output to this terminal. So what we can see is you'll be able to see whenever I log in and so forth into the cluster and so forth. So let's try this again. So administrator, let me enter my password here. Okay. So you'll see I just had to restart the tail process here. But what you can do, you can see at the bottom of that tail file is, I'm going to blow this up a little bit, is we had a successful login to the cluster. So this is a simple, I would say, audit record that we kind of, that Couchbase has spit out. And it kind of tells that the user, in this case administrator, has successfully logged in, and this is kind of the full, this is the local IP address and so forth. So what I'm going to do here is going and seeing this, this experience in Splunk. So I created this simple dashboard, as I said. And the dashboard has a couple of things. So it counts the number of bucket creates, bucket deletes, all the admin events. It also has a nice pie chart which shows actions for a particular administrator, login successes, login failures, incoming IP addresses. In this case, majority of them have come from my local host. And so forth. And you can build, depending on your the questions that your security officer asks you, you can build a very intensive and rich dashboard. So in this case, let me look at just the administrator login here. And you can see that, let me go back there. I'm just going to go directly to the widget for the successful login. So you see that we had multiple logins to this cluster, and this was a successful login that happened at 4:15. So in this case, you can see the time 4:15. You can see this is a successful login to the cluster. You can see the admin. If you expand on the username, you'll be able to see administrator and so forth. So exactly what you saw in the tail file, you're able to see the same thing in Splunk, because Splunk is just reading the same JSON log file that which I showed you in the console. So let's do something more different here. Let's create a bucket. So I'm going to, let's say I'm a rogue administrator. I'm going to have this travel sample bucket. Travel sample is a new app that we kind of are shipping with our 4.0 beta. So again, as the demo of this morning, you can try it out. But I'm going to just mimic myself as a rogue administrator who's going to delete this bucket. So let me delete this bucket. So the travel sample app bucket is gone, right? And what you can see again here is in the log, audit log, you can see that particular bucket was deleted. In this case, it tells you the bucket name, it tells you again the user, when the event occurred, and so forth. So if you go back to our UI, you'll be able to see initially it started with, we can create another bucket to see that. But we had counters for how many buckets were created and deleted. So in this case, you can see one of them should be 10. So both of them were 9 when we initially started with. But the number of buckets is right now 10 because we deleted the travel sample bucket. So exactly like that, let me try one more example here. I'm going to log out. I'm going to log in as hacker1 and just try to brute force the system. Again, you can't log in because there is no credential. Again, you get a failed login here in the console. And if you log into Splunk, you'll be able to see, if I just refresh this UI, it can auto-refresh as well. You'll be able to see that we have in the pie chart a new user that shows up here. And you can drill this pie chart down, so you can know exactly what are the events this particular user tried. In this case, it was an unsuccessful login. So that's pretty much it. I'd like to switch back to the slides now. So let me try this quickly. I just have a little bit power left on my machine. So this, for the roadmap perspective, what we see on the left column is what we have today. So what we have today, we have implemented is simplified compliance with auditing for admins. We also went through what we implemented for LDAP, supporting LDAP for admin users. What we plan to do next is work on fine-grained authorization and advanced compliance features. So what we mean by that is work on users, roles, permissions for admins as well as applications. So again, today we just have a single administrator and multiple administrators and read-only administrators, but again, segregating that line and dividing it further. Similarly for applications, we just have a single bucket username and a bucket password, which we kind of went over. Again, breaking that down into users, roles, permissions within that bucket entity. And finally, maybe in the future, work on more advanced compliance stuff, which is application auditing. I know there was somebody asked me earlier in the day, we're only doing auditing for admins. What about applications or data auditing? So that's something that we will also be looking at in the future, as well as external authentication for applications, where you can then use, once you have these users defined, you can then tie these users for your apps in LDAP. So you can now use LDAP credentials to kind of log in through your applications, to the buckets.
So that leaves us just a few minutes for any questions or comments people have. So, gentleman with the beard. I can't hear a word you're saying. Okay. So that question was, what about encryption of node to node? So are we going to be encrypting the data as they pass from one node to another? So that is an interesting question. Normally we expect things to be in a fairly tight-knit cluster where things are close to each other. But as we know in the real world, that's not always the case. So today you could be putting the usual SSL and the other pieces on top of that. But Don, is it in our roadmap to actually be encrypting node-to-node communications?
So we haven't got a lot of requests for node-to-node encryptions. I would definitely like to connect with whoever asked the question after the session to kind of understand your use case more. But one way in which we can kind of I would say solve that problem today is by using IPsec. Yes, it isn't a beautiful solution, but it's some way where you can encrypt your network between these nodes and set up your IP tables so that you kind of encrypt any communication between the nodes can be encrypted at the network layer. So that's one way in which you can solve the problem today.
Sir?
Do you have any plans to support LDAP groups, not just using user IDs?
So do we have plans to support LDAP groups beyond the user IDs?
Yeah, so that's a good question. So in the future, yes, we plan to support, that again is our enhancement of this LDAP work that we have done in 4.0. And that's where your input on the beta build is definitely going to be useful. These are items that we like to get, logged in our, in Jira and then track them and then prioritize them and so forth. Yeah.
So in the roadmap, do we have Kerberos with the SSL connections?
That's a good question as well. So that's again an item that we want to work on in the future. Again, today what we support is SSL between client and server and SSL between the cluster. But in the future, Kerberos support is definitely something that we would look at. Yeah.
So you get the honor of the last question, sir. So does this work with Red Hat Identity Manager, or what was the other one you threw out there? Oh, FreeIBA.
So at this point, what we have tested is, for our LDAP, I'm believing it's the identity management with LDAP. The piece works with just if your server supports OpenLDAP, the OpenLDAP protocol, we kind of just work with that out of the box. So that's our support matrix for now. I mean, definitely would like to learn from customers what are the different other platforms that you guys use in an enterprise, and then yeah.
So it should work with Red Hat Identity Manager. It should work with VOEA, right? Well, again, we haven't tested it. So we started with the Open LDAP. We expect that we'll have many, many use cases that we'll be testing and developing as it works forward in the product. So thank you all for joining us today, and I hope you go out and have an enjoyable and secure Couchbase Connect 2015.